Alright guys, let's go ahead and get started on the last day of review week. So starting on number 51, we have a trapezoid that says, what is the value of x in the trapezoid? Very, very simple problem. As long as you remember your properties of trapezoids, we know that this angle and this angle right here, the two bottom base angles, are congruent to each other. And we know that this top angle and this top angle are congruent to each other, but we don't care about that. We care about one base angle and a base angle from a different part of the trapezoid. Well, we talked about the property that they share with each other. We said these ones are consecutive, congruent to each other, and these are consecutive supplementary. So that means that this 105 and this x have to add up to equal that big old 180 that we keep using over and over. So if we subtract 105 from both sides, we'll cancel out here and we get x equals 575, and that is the answer choice B. Alright, here we are at 52. Given that the measure of angle PQR, so PQR is from P, that didn't change color at all. Why not? Oh, because I didn't do it right, of course. So, P to Q to R. So that red angle, it says that that PQR is 120 degrees. And it says, what is the measure of PQS? That's important. Remember, we talked about that. We should put an S here. We talked about that earlier this week, that if the question says, what's the measure of something, when I find X, I'm not done. So I need to make sure that I go back and plug into PQS, which is this top angle part up top. But let's start with figuring out what X is. We just said that PQR, the whole thing, is 120 degrees. So if I take these two things here and add them together, they should add up to get 120 degrees. So we get 9x plus 5 plus 2x plus 5 equals the whole thing, which is 120. So we'll combine this 9x and this 2x and get 11x. And we'll combine this positive 5 and this positive 5 and get positive 10. And it still equals 120. We'll subtract 10 from the left side, subtract 10 from the right side, and I get 11x equals 110, which is beautiful, because when I divide by 11, I'm just going to get the x equals 10. But I'm not done, even though that's one of our multiple choice answers. They made it answer choice A. I'm not done. Make sure you pay attention to that. It said, what is the value of PQS? So P to Q to S is this top angle up here, which is 9x plus 5. So we'll plug in 10 there. 9x plus 5 is now 9 times 10 plus 5, which is 90 plus 5, which equals 95. So we're going to choose answer choice D. Alright, we're on to 53. Didn't write anything, hold on. 53. 53 says quadrilateral ABCD is formed with A12, B35, C63, and D30, which could be used to prove that ABC is a right angle. Well, the first thing I need to do is decide what proves things are a right angle. Remember, in order to make a right angle, the slope of this line and the slope of this line must be opposite reciprocals. And so looking at my answers, A can immediately be eliminated because A says that the slope of AB is 2/3 and the slope of BC is 2/3. They're equal. It's not what I want. I want like B or C, which says they're opposite reciprocals. So it's probably going to be B or C. D says not enough information. I don't think it's not enough information, but we can leave it there just as a thing to check. So what I'm going to do is I'm going to go up and I'm going to find the slope in between A and B. I think that's a good first step because that will help us in eliminating one of the answers. So the slope formula is y2 minus y1 over x2 minus x1. And so I'm going to use A and B. So the y's of B is 5 and the y of A is 2. So we'll do 5 minus 2. And the x of B is 3 and the x of A is 1. So we'll do 3 minus 1. So up top we get 3 and on the bottom we get 2. So the slope of AB is 3/2. And if you take a look at your answer, that matches C. C says the slope of AB is 3/2 and the slope of BC is negative 2/3. We don't really have to do that next step because we have enough information to prove it. We could do that next one, and I promise you if you do it, you're going to get negative 2/3. So answer choice C would be the correct one. That is the one that proves that those are right angles with each other. All right, here we are at 54, and guys, it does not get any easier than a problem like this. It says, which property justifies that PR, I don't know what that's, it's late, PR is congruent to PR. It's the first mistake I think I've made, so it's okay. What verifies that something is congruent to itself, that A is equal to A, that stupid thing that we learned in the beginning? There is that one property. It is called the reflexive property. So C is the correct choice. C. Reflexive property. Reflexive property means something is equal to itself. Oh, I didn't draw the line there. There we go. There's the line. We're proving that this is congruent to itself. Reflexive property. All right, 55 says, which of the following lengths of triangles can be classified as an obtuse triangle? This could be a challenging problem if you're not really sure where to go with it, or if you don't have some good intuitive senses to get you going in the right direction. But what I first need to know is that c squared has a relation to a squared plus b squared in obtuse triangles. In an obtuse triangle, c squared always has to be the larger of the sum of a squared plus b squared has to be smaller than c squared. C squared's got to be bigger in an obtuse triangle. So I'm choosing C. Remember, C has to be the biggest number. So when looking through your four answer choices, I want to choose one that has a large difference between it and the middle one, the B. So kind of when I look at my answer choices, I see that 17 and 15 are the two biggest in A. It's only like 2 apart. Same thing with B. 14 and 12 are only 2 apart. So while it could be an answer, I'm going to lean more away from those. 18 and 14 in C, those are 4 units apart, so that could be a big one. Or D. D has 26 and 20 units apart. So I would lean more towards C or D being the answer. So I'm actually going to start with trying, let's try D. I'm going to work backwards in this. So we're going to try answer choice D first. So I'm going to plug in 26 squared, and we want to see if it's greater. Is it greater? We'll put a question mark above that sign. Greater than a squared and b squared, which is 15 and 20. I don't really have a calculator in front of me. Oh, well, that's going to be interesting. Life is hard. Life is hard. You know what? I'm just going to continue this one on the board when I have a calculator, because the problem is my calculator is my phone, and this is why your phone shouldn't be your calculator, because if you're using it to record things, then you can't switch around and have your phone and calculator be the same thing. See, guys, when you say, I'll always have my calculator, look, I have a moment that I don't have my calculator. So, well, yeah, I'll do this now. All right, we're on to 56, and 56 says, how many distinct line segments exist in the figure below? I'm telling you now, this is the most often missed easy question. It's missed a crazy amount of times. On your formative, there was like some stupid question about an ant ice skating, and like 75% of people missed it. And it's super, super simple. You just can't jump to conclusions. So I'm going to change up my colors here a little bit. So I'm starting off. I'm going to start off with what unique line segments can be made with V. Well, I can do V to W, so that's one line segment. We'll tally it up here. I could do V to X, so that's 2 line segments. I can do V to Y, 3. And I could do V to Z, 4. Now let's change it up and go to a different color. Now, I'm going to do line segments that use W. We could go backwards and do VW, but we already did that when we used V. So I'm just going to keep going to the left. So now we're going to do V to X. That's 1, so we're at 5 there. W to Y. W to Z. And we're done. So now we'll switch it up and we'll go over here to green. And we're going to start at X now. But again, we already did V to X and W to X, so I'm not going to go backwards. I'm just going to keep going forward. So now we have X to Y, and we have X to Z. I'm not going to change colors for this one. We're going to jump over to Y now. We have one more unit that we can do, Y to Z, which gives me 10. So there are 10 different line segments that can be made there, which is answer choice C. Make sure that you don't jump to conclusions on that one and miss a super easy question that just involves counting. Alright, 57. It says, what is the slope of a line parallel to the line given to the equation below? Remember, parallel lines have the same slopes. If the slope of one is m, then the other one has the same slope m. So we said new slope m and slope m are equal to each other. Well, this equation here, this 3x minus 2y equals 12, I don't know what the slope is, and I don't know why because it's not in slope-intercept form, which is easy to fix. Easy, easy. So in order to get to slope-intercept form, we have to get y by itself. So the first thing I want to do is I need to get the x's out of here. So I'm going to subtract 3x here and subtract 3x here. So 3x minus 3x cancels. I bring down my negative 2y, and on this side we have negative 3x plus 12. And now we just need to get the y by itself here. So in order to do that, we'll divide by negative 2. We'll divide by negative 2. So we cancel out here and we have y equals. Remember, this negative 2 is being divided to both things here. You can't just split up one of them. You got to split up both of them. So we'll start by doing negative 3 over negative 2. First thing I notice is negative over negative is going to go away. And I have positive now. So I'm going to have positives here. And I say 3 and divided by 2. Yeah, that doesn't do anything. We can't divide 3 by 2. So we'll just leave it as 3 over 2. And I'll move my x out here to the side. And then I've got 12 divided by negative 2. So we know positive divided by negative is going to give me a negative. And 12 divided by 2 is going to be 6. So I have the equation y equals 3/2 x minus 6. So what is the slope of this equation? Remember, the slope is always whatever's in front of x. So in this case, it's 3/2. So the answer choice B is the slope of this line. All right, number 58 says, what is the slope of the line perpendicular to the line given by the below equation? 3x minus 2y equals 12. That should look really familiar because we just did it. So go back to your last question. Rewrite that equation in slope-intercept form because we already did that. So we have y equals, it was 3/2 x minus 6. I think that's right. I don't have it in front of me because I had to erase it. But I'm pretty sure that was it. If not, you can yell at me in class like you will if I did it wrong, because I know you will. All right. We know perpendicular slopes have a relationship that m is equal to 1 over m negative, meaning that we take the negative reciprocal. Well, if the slope of this one is 3/2, then we're just going to take the negative reciprocal of that. What is the reciprocal of 3/2? Well, it means that we're going to take the denominator and put it on top and take the numerator and put it on the bottom. So my new numerator is now the 2. I move the 2 up top. And my new denominator is now what was the numerator, so it becomes 3. But then we have to do one more thing. That's the reciprocal. Now we need to make it negative. So if it was negative, we make it positive. Ours was originally positive, so we're just going to make it negative. So negative 2/3 is our answer, which happens to be answer choice C. All right, 59 and 60 are the same question, so we're going to do them all at the same time. 59 says angles A and D are not A and D. So A is right here and D is right here. A and D are not. Answer A says adjacent. Adjacent. Are these angles not adjacent? Remember the word adjacent? Adjacent is the same thing as next to or consecutive. Are A and D next to or consecutive to each other? Yes, A and D are next to each other, so that is a true answer. Answer choice B says A and D are supplementary. Well, we see that A and D make up a straight line right here. If they make up a straight line, then they must be supplementary, right? Right, Mr. Knock. Skip the next one. Go down to D. D says they're a linear pair. Well, if they're supplementary, then they're definitely a linear pair. Or, sorry, if they're a linear pair, then they're definitely supplementary. They go kind of hand in hand. So we know that because they're on the same line, they make up 180. That's the true statement. Go back to C. C says they're complementary. B said they're supplementary. They can't be supplementary and complementary. You only get to be one. Choose one. We already said that they make a straight line, so they're supplementary. So 59, the answer choice for what they're not, is that they're not complementary. Over to 60. 60 says B and D, so we're focusing on B and D now. B and D are not A, complementary. Well, do B and D... Oh, it's winning there, sorry. What are they? Are they complementary? Are B and D complementary? We don't know. We have no idea if they add up to 90. Same thing, B. Are they supplementary? I don't know. We have no idea. We can't tell that from here, but I don't really think so. We don't know for sure, so we're not going to choose either of those. C says they're adjacent, which means they're next to each other. Are B and D directly next to each other? No, because in between D and B, there's an A and a C over here and here. So we know that they are not adjacent. B and D are D. Answer choice D says they're vertical. Remember, vertical means that two lines are drawn, intersecting each other, and the angles that are on opposite sides. So B and D are vertical angles, and A and C are vertical angles. All right, here we're going to do 61, 62, 63, and 64. It says use the diagram below to identify the relationship between the two angles. 61 wants us to focus on A and H. So we've got angle H down here and angle A up here. We notice that they are both outside. Remember, this is exterior angles and exterior angles, and these four interior angles. Well, we see that H and A are both in the exterior. And are they on the same side of the transversal or opposite sides? Well, A is over here on the left side and H is on the right side. So they are alternate exterior angles, which is answer choice D. 62, let's change up colors so that we can keep track of what we're doing. 62 says we are focusing on A and E. Well, A is in the exterior and E is in the interior, so it's not going to be alternate or same side angles of any sort. So that leaves us with one choice out of all those. It's either it's got to be corresponding. Remember, corresponding means that if we were to like draw a box around here and a box around here, A and E are both the top left corner of that box. So A and E are corresponding, which is answer choice A. And next we got 63. 63 is D and F. So D and F, well, notice they're both in this interior block. So we are going to use same side or alternate interior. But they're both on the right side of the transversal, the other line. They're both on the right side, so they're on the same side. So they're same side interior, which is answer choice B. And last one, 64. Let's pick another color. We'll do orangish. It looks like it's actually brown. Whatever. 64 is C and F. This picture's getting a little bit muddled, but there's C, there's F. Again, they're both interior angles, right? They're both in this interior chunk. So they're going to be something interior. We just said D and F were same side because they were on the same side of this middle line right here. C and F, though, are on alternate sides. So it's going to be alternate interior angles. Alternate interior, which happens to be answer choice C. All right, on to the last page, home stretch. 65 says, write the converse to the following statement and give its truth value. The statement is, if a number is divisible by 6, then it's divisible by 2. So remember, we're going to use our C-SIC chart for this. C-SIC. C is conditional, which is what we started with. The other C is converse, inverse, and contrapositive. And we know that this one starts off as P then Q, and our converse is Q then P. Well, we're already where we need because we're just trying to figure out what the converse is. So P, the original statement, conditional statement was, P was if a number is divisible by 6. And the Q was, then it's divisible by 2. So now we're just going to flip it. So now we're just going to make if divisible by 2 first. So I took this second statement and made it the first statement. Then divisible by 6. So we just flipped it around. So that means there's only 2 possible choices that work. C, nope, sorry, not C. If a number is divisible by 2, then it's divisible by 6. B or D. B or D. One is false and one is true. So we got to kind of think about that. Let's start off there. Choose any number that's divisible by 2. I'm going to choose 4. We know 4 is divisible by 2. That's true, right? 4 divides by 2, we get 2. Well, does 4 divide by 6? I mean, it does, but not evenly. So is this statement true? Absolutely not. Numbers divisible by 2 don't have to be divisible by 6, so it's false. So the answer choice we're going to choose is B. All right, number 66. Felicia wants to install an island in her kitchen. Whatever. Bye, Felicia. Go install your island. I'm not helping. I don't want to do all that. Fine. Just because it's like the third to last one, I'll do it. So she wants to install an island in her kitchen. She wants to position the island so that it's equidistant from the vertices of a triangle formed by the sink. So we'll make the sink here, the refrigerator here, and the stovetop, which we'll put here. What is the point of concurrency she should use to position the island? So we've got a triangle, and we want a triangle so that the point that we choose here is equidistant from here, here, and here. So we got to choose what that's going to be. I want you to kind of go back a little bit. There were 2 really important things that we did when we did this project. We did a project in which we made all these different triangle shapes. There was one where you balanced triangles on your finger, and that was the centroid. It was the center of gravity. There was also 2 types of circles. There was one circle that we drew inside our triangle. We called that the in circle. Is the in circle equidistant away here, though? No. We see that this is going to be equidistant from the sides of a triangle. So anytime we talk about finding the equidistant from the sides of a triangle, we're going to use the in circle. But the one on the outside, this circle on the outside, it's a bad circle. This circle, its center has to be equal distance from all 3 vertices of the triangle. We call that one the Circum Circle. So if you're looking for the Circum Circle, what center do you need? Hint, it sounds the same. The circumcenter. C. Circumcenter. So, to help you out, Circum Circle finds the vertices of a triangle. It's equidistant from every vertice. And the in circle is equidistant from the sides of a triangle. So if they're looking for the vertices, equidistant from the vertices, we say circumcenter or circumcircle. If we're looking for equidistant from the sides, it's an incircle or an incenter. All right, 67 and 68. Did you listen to what I just said? Because I didn't read ahead, and I should have. And had I done that, I would have done it all in one problem. 67 says, what is the point of concurrency that's equidistant from the sides of a triangle? Well, I just showed you which one's equidistant from the vertices, and we said it was the circumcenter. And then I told you which one's equidistant from the sides of a triangle. It's 67 is in center. In center. Because that's the one that's equidistant from the sides. And then I said this one too. Which point is concurrency is the center of gravity of a triangle? That was the one where you guys walked around the room and balanced the triangle on your finger. That was the center of gravity, and we called that the centroid. Look at that. From paying attention, you already knew this, and I'm just wasting more of your time by repeating it. Stop wasting my time, Mr. Knock. I don't want it wasted. Here it is, guys, the final problem. We've made it. So, the final problem says, JKLN is a square. M is the midpoint of NL. Justify why JNM, triangle JNM, is congruent to triangle KLM. So we're using one of our side, angle, side, angle things. So we want to prove that this triangle right here is equal to this triangle over here. So let's break down the information they gave us. The first thing they said was, hold on, colors. First thing they said was that JKLMN is a square. Well, if that's true, that means that this side and this whole side, which I'm not going to do anything, and this side are equal to each other. And then it said that M is the midpoint of NL. So there's a reason I didn't draw anything down at N to L down here, this line here. And that's because that next statement is that M is the midpoint of NL. So M is in the middle of N to L. So that means that this piece here and this piece here must be equal to each other, right? So this piece is kind of useless to us because it's not really part of the two triangles we're focusing on, J and M and KLM. So we're not going to worry about that. So now looking at it, we're almost there. I have a piece of information here and a piece of information here, and a piece of information here and a piece of information here. So I only have two pieces of information in each triangle, and I need three to use one of my statements. So I got to go back and kind of look for a minute and say, what did I miss? Because I definitely missed something. M is the midpoint. Not much more I can do with that. But JKLN is a square. I said that the sides are equal, but there's something else important about a square. All sides are equal, and all angles are equal. They're equal to 90 degrees. So we know that all these angles are 90. So this angle right here and this angle right here are 90 degrees. So if I were to go label this, I'd label this an S and keep it because it's important. And I'd label this an A and keep it because it's important. And label this an S and keep it because it's important. And this angle, this side, and this angle are unimportant. So we have side, angle, side, which is answer choice B. You're done! Hurrah!